Although 70% of our planet is covered by water, less than 1% is potable water. Ever-increasing freshwater demands from growing populations and industrial activities have resulted in rapidly depleting water sources. The demand for more fresh water also means more energy is needed to produce fresh water. Common methods for large-scale desalination include traditional thermal desalination and membrane-based techniques such as reverse osmosis desalination. Memstil is a breakthrough technology in seawater desalination from Keppel, Seghers after more than 10 years of research and development. It is an innovative application of membrane distillation that achieves almost complete recovery of heat during distillation. Let's take a closer look at the process of Memstil desalination. Raw seawater is drawn from existing seawater bodies. The raw seawater is first passed through a particulate filter stage comprising auto strainers and granular media filters. This is to remove suspended solids and foreign matter. The raw seawater is next purified with a vacuum spray degasser, removing part of the dissolved gases. The heart of Memstil comprises units of condenser and membrane arrays placed parallel to one another. As seawater flows up from the bottom of the condenser array, it absorbs heat from the membrane array and progressively heats up. At the top of the condenser array, temperature of the seawater is raised with waste heat before it flows into the membrane array. Within the membrane array, pure water vapor evaporated from the hot seawater passes through the microporous membrane while the rest of the seawater is retained. Following the thermal gradient, the evaporated water from the membrane array travels towards and condenses on the surface of the condenser array. The retained seawater flows down the membrane array and simultaneously releases heat to the condenser array, allowing efficient internal recovery of evaporation heat. The ultra-pure water produced is collected in the distillate tank and is now ready for use. Memstil desalination has many advantages. The highly efficient heat recovery dramatically reduces energy requirements, allowing Memstil desalination to use low-grade or even waste heat from sources like power plants. Memstil can also be engineered to use renewable energy sources like solar energy and geothermal energy. Memstil plants are modular and are more compact than traditional desalination plants. With the use of low-grade heat for desalination, the energy requirement for Memstil is much lower than current techniques. The Memstil modules can also be configured to suit capacity and space requirements. The integration of Memstil into the freshwater system on board ships using waste heat from engines is a convenient way of supplementing purified water. The potential uses for the ultra-pure water derived from Memstil technology are endless. In the petroleum refining, waste incineration and thermal power generation industries, the water can be used as boiler feed. It can also be used in industrial sectors where high-grade processed water is key. Other applications include freshwater manufacture on board ships, food and beverage processing, and perhaps most importantly, for human consumption. Let us continue to strive to preserve a sustainable environment. Here's to a cleaner future with Keppel Seghers.